Light with an energy flux of 25 into 10 to the power of 4 watt per meter square falls on a perfectly reflecting surface at normal incidence. If the surface area is 15 centimeters square, the average force exerted on the surface is what we need to find. The force we need to find here. Okay. We know that force is equal to P divided by time, T. Then the P, that is the momentum delivered, P is equal to 2U divided by C. Then U is nothing but 2 into I into A into T divided by C. Then by substituting the value, F is equal to P, that is P is nothing but 2 times I into A into T divided by C whole divided by T. If T will get cancelled, then the remaining equation is 2IA divided by C. Then the average force is force F is equal to, substituting the values, 2 into I is 25 into 10 to the power of 4, and A is equal to 15 centimeter square. Centimeter square we are going to convert as meter into 10 to the power of minus 4 whole divided by C is, that is 3 into 10 to the power of 8. If I get cancelled, 3 1 times and 3 5 times, 10 to the power of 8 I will take to the numerator, 2 into 25 into 10 to the power of 4 into 5 into 10 to the power of minus 4 into 10 to the power of minus 8. Then 2 into 2 times 25 is 50. 58 to 5 is 250 into 10 to the power of, this will get cancelled, minus 8 is there, in the power of minus 8 is there. So this is the force. But here the options they given in terms of 10 to the power of minus 6. If I'm going to write this one in the 10 to the power of minus 6, then this becomes 2.5 into 10 to the power of minus 6 force, that is Newton. So 2.5 into 10 to the power of minus 6 Newton we get in the option number B is our right answer.